Hello, everybody. We are back and we are going to jump into part 1, and we're talking about graphs of functions. And so and we've been using it, that the graph of a function is the collection of ordered pairs, where basically we're looking at this ordered pair of x comma f of x, and that, that y value is equivalent to the f of x. And x is the domain of f of x. Another way to look at it is that x is the values of the directed distance from the y-axis, and the f of x values, or the y values, okay, is the directed distance from the x-axis. Okay, you all know all that. That's no big deal. And so we're going to talk about a little bit more in depth finding the domain and the range of a function. So in order to find the domain and range of the function, we have to use the graph. I shouldn't say we have to. It is very helpful when we can use the graph of the function because it makes it visual for us, and it just makes it so much easier. So for part A, we're going to find the domain. So here we go. Remember, keep in mind that the domain values are the x values, right? So this is kind of hard to follow sometimes because our x values are right here along the x-axis. But the domain tells us what's going on in the function for those values of x, right? So we have to kind of look at the function, okay? We see that the function starts here. It goes up and it comes down and it ends here, but keep in mind it does not include that 4. So we're looking here basically, and we're saying, okay, it starts here, so we're going to bring it up. So it starts here on the 1 value, and it keeps going. So it keeps going until we get to this open value on 4. So basically, it starts at -1 and ends at 4, but doesn't include 4. So how do we say that? We're going to use interval notation because it's easiest, but remember, there was this dark spot here on -1. So since it's a closed hole here, we can include that value of -1, and it goes all the way. I hope you can see my pointer. It goes all the way to 4, but doesn't include 4. Okay. All right. So part 2, or part B, it said to find the values of f of -1. So all we have to do is find, okay, well, here's where x equals -1. And we follow that down to our f of x value at -1. And we see that this is, if this y-axis is the same thing as our f of x axis, we see that value is -1, 2, 3, 4, 5. So we say it's -5. And then similarly, to find f of 2, remember this value is our x value. So we go over at x is 1, 2, and we follow it up and over to see that corresponding value for f of x. And we see that it's 4. And then lastly, we're going to find the range. So keep in mind that the range is the y values. Okay, so our y values, if we're looking at the overall image for the function, I'm going to clear all this so that we can see this clearly, okay? So we're looking at our overall values on the function. It's taking so long. That for the range, we basically just want to know, like, what's going on with the function and what's our top value for y, and see how it kind of goes down and it goes to our lowest volume, our value for y in this regard. So we see the top value for the y is 4 and the bottom value for the y is -5. So we say the range starts, remember we always go from least value to the greatest value. So it starts at -5 and ends at +4. Okay, so remember the domain are the x values. So we went from -1 to 4 for the domain. And for the range, we really looked at the y values, which were this top to bottom. Okay. Let's look at example 2. Let's find the domain and range of a function. So what if it's not being graphed? Okay. What if they're just giving it to us in our function form? So remember that the domain is what our x values can be. Now, if we kind of practiced this in our last homework, right, where we see that there's this root. And we know for a root, we know we can't have a root be a negative. But it can be 0 and it can be positive. So that value of 0 is kind of that tipping point. Once we get past 0, it doesn't work for us. So we want to see where does x minus 4 equal to 0. So I want to know what's the stuff inside of here. Where would it equal to 0 so that we don't go any less than that? Okay, so we're just going to solve this. Add the 4. We get x equals 4. So we know x equals 4 is kind of that tipping point where if we go any less than that, we'll have a negative value. So for our domain, we're going to say the domain is basically nothing less than 4. So we're going to say we're starting at 4 because it can equal 4, and it's going to go to positive infinity and end right there. Okay, so let's talk about our range. So for our range, it's the y values, right? Our range is discussing our y values. We want to make sure that we're including all of them. So here we go. I'm going to erase this a little bit. Here's our range. And is there any value that f of x won't become? So remember, this is tied into this root. Remember how we talked about a root can't be negative. So the whole root can't be negative, which is basically what f of x is. So what we know about f of x is that it cannot be negative, which means it can be 0 or anything positive. So we're going to start with the range. It starts at 0, and it can be positive infinity. Okay. The other way you could have written that without interval notation, which I think interval notation is easiest, but if you like it better, we can say that the range is the set of f of x such that f of x is greater than or equal to 0. We could have also said the non-interval notation for the domain could have been the set of x such that x is greater than or equal to 4. I think it's personally easier to do interval notation, and it saves time. Okay, so now let's talk about this idea of a vertical line test for functions. So we've talked before, probably in your former classes, about not every relation is a function, right? A very specific set of values is a function. It's only when we have an individual value for x and it has its corresponding value for y, okay? Basically, the x's cannot repeat. We can't have two values of y for one individual x, okay? So one of the ways that we can test to see quickly if something is a function is when we're given the graph, we literally draw a vertical line anywhere on the graph, maybe multiple times, and if it hits it more than once, it's not a function. If it hits it only once, then it is a function. So that's our vertical line test. So we can see here in example 3, we're using the vertical line test to see if this is a function. And we can see the line that they drew in here, it hits it twice. So because it hits it twice, we know this cannot be a function. So we know that figure A is not a function. And if we come over here to part B, we see that this is curvy. But when we do our vertical line test, it only hits once. And you can draw it multiple times to verify. In all of those places I drew a vertical line test, it only hits once. So this is a function. Okay, to compare, I could have drawn a vertical line test here and it technically only hits once right there. But anywhere else that I drew the vertical line test on that graph, it's going to hit it twice. Okay, so make sure that you can draw that line anywhere. Okay, so now we're going to talk about increasing and decreasing functions. Okay, so what do we know about increasing? So, well, in our everyday lives, if something is increasing, it's going up in value. If something is decreasing, conversely, it's going down in value. So in a graph, we can see when something is increasing because it's going up. So like this part of this graph here, we can see that it's going up. Here on this part from left to right, we can see that it's going down. That's called decreasing. And this part in the middle, it's called a constant because it's not really increasing and it's not really decreasing. It's just a constant, okay? So when we look at these graphs, we always look at what's happening from the left to the right. We never want to go backwards. We always want to go from the left values of x to the right values of x and see what's happening in the graph. Okay, so formally, a function is increasing on an interval when any lower value of x and the higher value of x in the interval where this is less than this implies that the function of f of 1 is less than the function of x2. Basically just means if I'm going from left to right, it's increasing if the y value on the left side is lower than the y value on the right side. Okay, a function's decreasing on an interval when you have two values of x where this is less than this in the interval, and it implies that the function at the first point is higher than the function of the second point, meaning it's decreasing, it's going from high to low, and it's constant if those two values stay the same. Okay, so let's practice with this. We're going to look at these three different graphs, and we're going to see, okay, where is it increasing and where is it decreasing? Keep in mind, we're always going from left values of x to right values of x. So if I follow my finger along the f of x, I go from down low here. This is way down here. It's the lowest value of the function. It goes up. It keeps going up and ends up. So we actually never stopped increasing. And I know in here it kind of looks like it stays flat, but it doesn't. It gets really close to 0 and then it continues to increase. So actually this is increasing the whole time. Okay, this is increasing the whole time. So we would say it's increasing from negative infinity to positive infinity. Okay, and it's not decreasing at all. Okay, So what about for this one here? So remember, we're going from left values to right values. So we're going to put our finger on the function. Go ahead and put your finger on the screen with me. And we're going to start from left to right. So we're going from left to right. So I'm increasing up to this top point right here. But now what's happening is I can't increase anymore. I'm going down. So I know I'm decreasing to this bottom point. And I'm not going down anymore. I'm going back to increasing. So we're actually increasing on two from left to right here and from left to right here. So we're increasing in two places like this. And we're decreasing from here to here. So let's kind of write that out. So we're increasing from where X is over here, right? And we're increasing to this point here, which is at -1. So we're increasing, we'll say, from negative infinity to -1. Now, there's this thing about increasing and decreasing values. It only goes to -1, but it's not still increasing at that value of -1. Technically, at the value of -1, it's standing constant. So we close it with the parentheses, okay? But then we have this other side where it's increasing from this point up to this. So we start here where that X value is 1. So we are going to join this. Let me give myself some more room. We're going to join that increasing value. We put that big U, which just basically means join or union. And we're starting again at 1. And it keeps going forever. So we go to infinity. So that's our increasing intervals. And then we know from here to here, it's decreasing. So from where X is -1 to X is +1, it's decreasing. And again, when we're talking about increasing and decreasing values, we only use parentheses because at those points, they're not actually increasing and decreasing. They're kind of changing directions. But so for our interval notation, we use parentheses on this for increasing and decreasing values. Okay, so let's talk about part C. Here we go. We're going to look for our increasing and decreasing values. So again, we're going to put our finger. We're going to go from left to right on the function. So here we go. Put your finger on there with me. We're kind of going up until this point, and then we're staying constant, and then we're going down. So we're increasing from here to here. We are staying constant from here to here. And we are decreasing from here to here. So let's list where are we increasing. So we know those values, remember this is going to go from left to right. So we know our increasing is going from, remember we always go from smallest value of X to largest value of X on the increasing interval. And we're increasing from -infinity to this point right here, which is that X value of 0. Okay, now they are not asking us when we are, actually they are asking for constant. So when are we constant? So we're constant from that point of 0 all the way to X equals 2. So we say from 0 to 2. And then we know we're decreasing from 2 to positive infinity. Okay, and that's it for part 1.